Okay, folks, let's take a look at this example. We've got a W12 by 50. Again, you can find the properties to that shape on 602, 603 in your text. And again, we're asked for maximum bending moment. We have a beam, 20 kip load in the middle of the 10-foot long beam. So again, you know, the bending stress formula is MC divided by I. But one of the things we're going to need right off the bat is we're going to need, you know, our bending moment. If we ask for maximum bending stress, we want the maximum bending moment. So again, we'll want to do the shear and moment diagram on this. Pretty easy, okay? But nonetheless, get your reactions right. Shear diagram goes up to 10, goes over to the concentrated load of 20. That 20 brings us down to a negative 10, and then back on over when we get to the right-hand reaction. Okay? We add up the areas of the rectangles, 10 kips times 5 feet, excuse me, plus 50 foot kips. This one's minus 50 foot kips. So again, we go up to 50 and then back down to 0. Okay? So our maximum moment here on the beam is 50 foot kips. Right? Okay. Now, we got two other pieces because our bending stress formula is MC divided by I. We found what the bending moment is, 50 foot kips. What's the C distance? Well, again, the C distance is, we're asked for maximum, so it's going to be neutral axis to the outside edge. But this is a steel shape. So what are we going to do? Well, we're going to go to the tables. We're going to find that steel shape. All right? And W12 by 50, it doesn't have a half the depth column, but it does have a depth column. So you can look at a 12 by 50 and the depth that's given to you in the table is 12.2. That's the overall depth from top to bottom. So what's my C distance? Half of 12.2, that's 6.1. Okay? The last thing that we're going to need is moment of inertia. Now again, moment of inertia about centroidal axes for standard shapes like these steel shapes in the tables, they're going to be given to you. So that's called the x-axis, the centroidal axis that it's bending about. We go over and we find the column that's marked axis, XX, and we look for a column that's marked I, moment of inertia. And for a W12 by 50, it's going to give you a value of what? 391 inches to the fourth. So, our formula then for maximum bending stress in this problem is 50 foot kips. What am I going to want to do there? And multiply by 12 at least to get it into inch kips, times the C distance, 6.1 inches, divided by the moment of inertia, 391 inches to the fourth. Okay? And when I get my bending stress, I calculate that out, I'll get what? 9.36. Units would be what? KSI. Okay, questions? All right. Now here's one thing that, again, some people do, especially when they're using standard shapes, is instead of using the formula MC over I for bending stress, they will use a formula that's written as M over S. S stands for the elastic section modulus. Okay? And S, the elastic section modulus, is simply the ratio of moment of inertia about an axis divided by half the depth. Okay? So all S is the ratio of I over C. And when you use standard shapes, you'll find that most tables will also list a value for S, section modulus. And it provides a little bit of a more streamlined way to calculate your bending stress. Because instead of having 3 things you got to worry about, you really only have to worry about 2. And the S, the elastic section modulus, like we said, is a value out of the table. So I could have done this very same problem, and you would have told me I got 50 foot kips a moment, right? And you would have said, hey, change that into inch kips. And I could have looked into the table for W12 by 50, and I could have pulled out the elastic section modulus, which would have been what? 64.2. Now notice its units are only inches to the third, so again we're going to come up in KSI. And when I do that, what do I get? Okay, same thing. Okay. So again, you can use either one. A lot of people, when they get the standard shapes like steel shapes or even lumber sizes, like if you're using a 2x10, a 2x10 always has, it's always the same shape, so it's always got a certain depth, it's always got a certain half the depth, so it's always got the same moment of inertia. So a lot of people will use this instead. Okay, you do not have to use that. It's just you're allowed to use it.